beautiful people, and welcome. In today's video, we're going to be talking about factoring trinomials of higher degrees. Now, a trinomial has three terms, and so it's a three-term polynomial. Now, the higher degrees that we're going to be talking about is going to be 3, 4, 5, etc. And the most common ones are 3, 4, 6 is a common one, 8 is a common one. Typically, we don't see 5 unless you can pull out something. So we'll talk about the methods of doing that. As always, I am human, so if I make a mistake, that's okay. I would like to learn from my mistakes. Just let me know where the mistake occurs, and that way I will learn. And then you can learn from my mistakes as well. Let's go ahead and get started. Now, I'm going to talk about a method of factoring these higher degree polynomials. And this is called U substitution. Now, it doesn't have to be the letter U. It can be whatever letter you like, but typically U is what we use. However, if you have a polynomial that needs to be factored that has U, then just pick another letter. It doesn't matter what letter you choose. So the objective is you're going to let U equal to something squared. That way, you end up with a quadratic, or with the highest degree of 2. Once you do that, so you let U equal to a bubble squared, and we're going to do an example, so it's going to make a little bit more sense here in a second. But once you set a bubble squared equal to U, you're then going to have U squared equal to something, but you're going to use U and U squared in your polynomial. And then you're going to factor as usual. You can use the diamond method, guess and check method, the slip and slide or slip and divide, whatever we call it. Reverse, FOIL, all of those methods, because it is a three-term polynomial now. And then once you have factored it, put back or remove, let's say remove U and U squared and put back or resubstitute what U is equal to and what U squared is equal to. And this is the really important part. Keep factoring the bubbles. That doesn't mean you're done factoring. You have to take those bubbles that you have, you have to take those groupings that you have, and then keep factoring until you cannot factor anymore and you have something that we call prime. So again, let U equal to something squared. That way you end up with a quadratic polynomial. Then you will have U squared is equal to something. You can use the U and the U squared in your polynomial. So you're going to substitute U and U squared into your polynomial. Then you're going to have a standard quadratic polynomial with an exponent of 2. You're going to factor as usual. Then you're going to remove the U and the U squared, whichever one you have, or you may have both. And you're going to put back, or you're going to resubstitute what U and U squared was originally. And then you're going to keep factoring. So the best way to learn is through an example. So let's jump right into an example. And let's start out with an example. I'm trying to get a good example here. Here's example 1. We have x to the 4th power plus 6x squared minus 40. And our objective is to factor. So notice that now we have a polynomial of higher degree. This is a trinomial. It has 3 terms. However, the highest degree is a 4. Then we have a 2. So it's not a quadratic. So the highest degree is not 2. It's not x squared as my highest exponent. So the step number 1, what you're going to do is you're going to let let's back up a little bit. Let's back up. This works when you have the exponents being double each other. Let's back up a little bit, because I never told you why we can use this or how we can use this. So not why, when. When's the correct word. When we can use this. So you can use this when the highest exponent is double 2 times the second. You can say the other exponent. So, for example, here's my exponent. I have an exponent of 4. And then I have an exponent of 2. So the highest exponent is 2 times 2, which is 4. Therefore, U substitution will work. 2 times 2 is 4. Therefore, it will work. So let's go back to our U substitution. We're going to let U equals bubble squared. So what are we letting U equal to? We're going to let U equal to this x squared right here. If we can factor, if 6 was a 9, we can do 3x cubed, and right here was a 9 as well. We can have a coefficient. Typically, you don't, though. So we're going to let U equal to our x squared. That means that U squared, so if U is x squared, if I square both sides, that means x squared is now going to be squared. That means I have U squared equal to x 2 times 2. So I have U squared equals to x to the 4th power. So now I have U and I have U squared. So what am I doing with that information? So I have U, and then I have U squared. I'm going to replace in my polynomial. So I'm going to use the U and the U squared in my polynomial. I'm going to substitute that. So instead of saying x to the 4th plus 6x squared minus 40, I'm going to say I have U squared plus 6 times U minus 40. Okay, now that we have a standard trinomial, highest exponent is 2, we're going to use either the diamond method, the slip and slide method, the reverse FOIL, whichever method you choose. I'm going to use the reverse FOIL, which is the guess and check method, because I know there is no coefficient. There's no number in front of U squared, so I know that I'm going to have a U here and a U here. So I need 2 numbers that multiply to 40. However, when I add them, they give me positive 6. If you'd like to use the diamond method, that's fine. 2 numbers that multiply to negative 40, but when I add them, give me a positive 6. So 40, I'm thinking 10 and times 4 is 40. 10 minus 6, just kidding, 10 minus 4 is 6. So I'm doing positive 10 and negative 4. So then I'm taking these and I'm doing a positive 10, negative 4. Now that you have factored this, we're moving on to the next step. And the next step is to remove the u or the u squared, whichever one you have. In this case, we just have u. So we're removing the u and we are replacing what we had originally. So u was equal to x squared. So now I have x squared plus 10, and I have x squared minus 4. Are you done? And everyone says together, no. We have to keep factoring the bubbles. So this is not done. We're going to take these. You're going to rewrite them. And you're going to check each bubble if it is factorable. So because you have now 2 terms in a bubble, so you're going to check if this term is factorable. You're going to check if this term is factorable. I'm going to take out my graphic organizer, my cheat sheet. If you haven't seen that video, go ahead and watch that video. And I'm looking now for 2 terms. So this is a polynomial that needs to be factored. This is a polynomial that needs to be factored, but I'm looking for 2 terms. So 2 terms, I'm going to go to page 2. Here's my page 2. For 2 terms, I either have difference of squares, I either have difference of sum of cubes, or I have the difference of cubes. So I don't have a cube because I don't have x cubed. So I know it's not the difference or the sum of cubes. This is out. The only option I have is the difference of squares. So that means bubble squared minus bubble squared. So I'm looking for a bubble squared minus bubble squared. So here I have a plus. So this is not the difference of squares. So this is prime, and you cannot factor. So it stays the same. Now this bubble, again, I need bubble squared minus bubble squared. So I have x squared minus, and I know that I can rewrite 4 as 2 squared. So I'm going to say this is bubble squared minus bubble squared. Now that I have x squared minus 2 squared, I'm looking at what this factors to, and this factors to a plus b times a minus b. So this now factors to a plus b, a minus b. Now, this we already said is prime. However, if you keep factoring, you have to double check every single bubble, that each bubble cannot be factored further. So this is prime, we can't factor. This is singular, meaning the exponent on x is 1. And if the exponent on x is 1, you're done. There's nothing to factor anymore. It's as simple as it can get. So therefore, this is our final answer for the original polynomial, x to the 4th power plus 6x squared minus 40. So if I was to multiply this out, it would give me the original polynomial. Again, factoring is undoing that multiplication. So when we do multiply, we can get our original polynomial. Let's do one more example. Let's do x to the 4th power minus 81. Again, we can still do U substitution. The steps are going to be a little bit different though, because I said here, where is it? Use this when the highest exponent is double 2 times the second or the other exponent. And I said I'm going to give you 3 terms. Here's an example of 2 terms. And I wanted to show you this example, even though in the title I said there's going to be 3 terms. This is 2 terms. And the reason I wanted to do that is because we can still use U substitution if we want. So let's say U is equal to x squared. So U squared is equal to x to the 4th. So if I have U squared equal to x to the 4th, this is U squared minus, and I know 9 squared is 81. Now you don't have to do it this way, but you can use substitution whenever you need to. So then this right here is we just did it. This is two terms with a minus in between. That means I have a difference of squares. So I have u minus 9 and I have u plus 9. Again, reintroduce whatever u was. U is x squared minus 9, x squared plus 9. Again, now we have two terms here and we have two terms here, so we have to double check. Is any of them difference of squares? We know it's not the sum of cubes because we don't have a cube. This right here is a plus, so this is prime, can't do it. However, this one here is x squared minus 9, which I know I have x squared minus 3 squared. This again is the difference of squares. So I have x minus 3, x plus 3. The highest exponent on the x is now 1, so we're going to bring down our other bubble, which was prime, and then here you have your factors. Just wanted to show you that if you wanted to do U substitution with something that is a binomial, two terms in it, you can. Now you don't have to. I'm going to quickly show you how you could have done this without it. You could have noticed that we have an x to the fourth and 81. 81, things like 81, 64, 1. Oh my goodness, I can't stress it. The number 1 is magic when you're factoring because 1 can be squared, that's 1. 1 can be cubed, that's still 1. 1 is magical. And here we have x squared squared. So you didn't have to use U substitution. So if you notice here, then you could have immediately jumped to this is your A bubble, this is your B bubble. So we could have done x squared minus 9, x squared plus 9. Now you didn't have to see that if you have the U substitution, it works out the same way. You can see this without U substitution, that's okay as well. Let's go back to a trinomial with 3 terms, and I can give you one more example of that. Let's give you one that you have to, let me see if I can get a good one for you. Let's do this one. Example 3. 12x to the fourth plus 12x squared minus 189. Now, one thing I notice is I have a 12 here, a 12 here, and 189. And I think 189 is divisible by 12. So if it is, we have to pull out our GCF. So step number 1 here is check for GCF. And this step number 1, check for GCF, that kind of shouldn't be mentioned because that's always your step number 1. Even when I'm not expressing, even if I'm not saying it, that just means I didn't notice a GCF. So if you notice a GCF, you can pull something out. Please make sure to do so. 189 divided by 12. Ooh, then it's not divisible. 189 divided by 12 is not divisible by 12. So let's see if something else. What else? 3 times 6, maybe 189 divided by 6. Nope. What about 189 divided by 3? Ooh, 3 can be pulled out. So if I pull out 3, so I have 4x to the fourth power plus 4x squared minus 63. So 3 was able to be pulled out. Now that we have here, oh, I like this example because remember how I said in example number 1 that you can have a coefficient in your U? Maybe we want to do this, maybe we don't. It's your call. So if I was to set all of this equal to U, would it work? And it would not work. So I would have to say, leave the 4 out because here's my thought process. Here's my thinking bubble. If I have U equal to 4x squared and I was to square both sides, that means I have to also square the 4. That means I have 4x squared times 4x squared. That means I would have a 16x to the fourth. But that is not what we need. We need a 4x to the fourth power. So we can't do that. So I'm going to say that's not what I want. I'm going to say just do x squared. So that way when you have U squared, I have x to the fourth power. So we're not going to take that 4. We're just going to take that x squared as our U. And then our u squared is x to the 4th power. And again, I know I can do this u substitution because 2 times 2 is 4. Keep your 3. I'm going to kind of write out our answer down at the bottom just so we know that 3 is still in our answer. We just factored it out to make these numbers better. So let's rewrite this as 4u squared plus 4u minus 63. You can use the diamond method or you can use the slip and divide method. I'm going to choose to use the slip and divide method. So that means I'm taking 4, moving it over to 63, and I am going to, multiply. 63 times 4 is 252. Now I'm going to do the factoring, reverse FOIL. So let's see. Two numbers that multiply to 252, but when I add them, it gives me 4. So I know it's going to be a big number. I'm going to randomly start talking about factors of what goes into 252 when I multiply. I know 2 does, but 2 is probably going to be too small. So let's try 252. Let's try 24. 24 doesn't work. 252 divided by 26. Nope. I'm still looking, you guys, because I know, 14 and 18. 14 and 18 worked. So 14 times 18 is 252. So I need it to be negative. However, when I add these, I need them to be positive. That means my negative is on the 14, my positive is on the 18, and I have u and u. Now we have to go back in and redo the substitution that we did. So u was x squared. So I have x squared minus 14. And I have x squared plus 18. Now you're not done. Remember, with the slip and divide, you're taking your original coefficient on your highest term or in your first term, your leading coefficient, and you're going to put that underneath your factors here. After that, you're going to simplify that fraction. So x squared minus 14 divided by 4, that is 7 halves. And then I have x squared plus, and then 18 divided by 4, that is 9 halves. The denominator, now the denominator gets picked up, and that is your new coefficient on your x squared here. So then I have 2x squared minus 7, and I have 2x squared plus 9. These are two terms, so now I have to double check if they are, again, here's my cheat sheet. I have it in front of me, you guys, always. Difference of squares. I have bubble squared minus bubble squared. I need to check if that can happen. I can't have 2 squared. I can't have a bubble squared here because of the 2. 7 can't be squared. I mean, you can, it's just not going to be pretty, so we're not going to do it. Same thing here, but we have a plus here, so that won't work. So then we're going to bring these over. And this is our final answer. Now, these 2 examples, or these 3 examples I did with the highest exponent being 4. However, you can do 6. If this one was a 3 and this was a 6, 3 times 2 is 6, so you can do that. If this was a 4, 4 times 2 is 8. You can have an 8 and a 4 here. I mean, you can do this for any of them. Just make sure on the last step that you check to see if these are prime, if we can factor further or we stop. If they are prime, if you cannot factor any further, that means those are your end bubbles, those are in your final answer. However, if you have something that can factor, please factor further. Look out for numbers that should be an alarm in your head, like 1, 4, 9, oh, I don't know what else, 8, because 8 is 2 cubed, things like that. All right, beautiful people, thank you so much for watching my video. Use U substitution. It's great, and I will see you in my next video. Bye.